Okay, good day. This is Honors Algebra 2. I am Mr. McCulley, and this is the video presentation for Section 3-8, Inverse Matrices and Solving Systems with Matrices. And so today we are going to use matrices to do something that's fairly practical, and that is to solve systems of equations very quickly. So our learning goals are to find the inverse of a matrix, and we're going to need to find the inverse of a matrix to solve that system of linear equations, and then we're actually going to do that in our second goal. So first, we need to talk about the identity, and in regular addition and multiplication, there are values, and so an identity is basically when you do that operation, you get the original back. And so in regular just multiplication, so I'll come over here and I'll do one. So if I take 3 and I add 0 to it, I get 3. And if I take 4 and I multiply by 1, I get 4. So these things right here are the identities. So 0 is the additive identity. And 1 is the multiplicative identity. Matrices also have identities, and a matrix when multiplied by another matrix will give the original matrix. So there are only square matrix identities, and so one of the identities for matrices will be a 2 by 2 matrix, and it will be 1 0 0 1. And then for a 3 by 3 matrix, you'll have 1 0 0 0 1 0 and 0 0 1. And again, identity matrices can only be square, and you'll notice that they'll have ones down the diagonal and zeros everywhere else. And that's the only way that you're going to get a matrix identity when you multiply it by itself. And we can prove that real quick if we go to Desmos, and here's Desmos, and again we're going to go to our math tools, and then we're going to hit matrix calculator. And so first thing we're going to do is we're going to hit new matrix, and we're going to go 1 enter, or 1 arrow, 2 arrow, right arrow, 3 right arrow, 4 right arrow. We're going to hit enter. We're going to hit new matrix, and this one we're going to make an identity matrix. So 1 enter 0 enter 0, and I apologize, it should all be right arrows there. And so 0 right arrow and then 1, and then we'll enter that. And if we go A B, you'll notice I get the original matrix back. So the B is our identity matrix. All right. Finding the inverse of a 2 by 2 matrix by hand. Now I'm not going to make you do that, but if you were given a 2 by 2 matrix, the way that you would set it up is you would label A, B, C, D, these 4 elements in this matrix, and the inverse, which is going to be noted by a what looks like a superscript -1, and it'll be 1 over AD minus BC. And when I say AD, it takes this value here multiplied by that value there, and then subtract from that the B value times the C value, and then you would take this expression and you would switch the A and the D. So I'm switching A and D, and then I'm making B and C negative. Now we're just going to use the Desmos calculator this year to find the inverses of both 2 by 2 and 3 by 3 matrix, and that's going to save us a lot of work. And the way that you do that in Desmos is, I'm going to hit enter here. So Desmos has kept A and B both in its memory, and so if I want to find A inverse, and that's how I'm going to label it, I'm going to hit A, and then you'll see down here there's you can square a matrix, you can find the inverse of a matrix, you can transpose a matrix, we're not going to talk about it, and raise it to a certain power, but we want that value there. You'll notice that these values have decimals in them, and so I would prefer it if you had fractions, and we can rectify that pretty quickly just by hitting that convert to fraction button, and now we have all fractions there. And so that's what the inverse of A is. And that makes a lot of sense because clearly we're multiplying by a scalar that's going to be a fraction, and so if you multiply a bunch of whole numbers by fractions, you're going to get fractions in it. And so the inverse of a matrix, and what we're going to do here is we're going to formally define what these inverses are. But most operations have inverses. Addition and subtraction are inverse operations. Multiplication and division are inverse operations. Square and square root are inverse operations. And so to find the inverse of a matrix, we're going to use this X inverse button. And on Desmos, or on the old graphing calculators, it was X inverse, but in Desmos, it's going to be A inverse, this button right here. And again, we should use the fraction conversion tool, because when you inverse matrices are usually going to give fractions as part of its answer. And so now we have a couple of methods for solving systems of linear equations. We have substitution, we have row reduction, we have graphing. But now we're going to have matrices. Now matrices are really cool because they will do the operation very, very quickly. And I'll show you that here in a moment. But they do have a couple weaknesses. They will not find parallel lines, and they will not find the same lines. So you just have to be careful there. And if you get an error, you may have to do a little bit more work. All right, so if we are going to solve a system of linear equations using matrices, what we're going to do is we're going to take this system, and here's our system. It's 5x minus y equal to 9, and then it's 4x minus 4y equal to 2. And the way that we're going to set it up is we're going to set up a system of two matrices, and the first matrix I'm going to call my coefficients matrix, because it's going to be the coefficient of all of these values on the left hand side. And then I have a constants matrix, and so that constants matrix is going to be just the values that are by itself. And so this matrix here I'm going to call the coefficients, coeffficient. And this one is going to be my constants, constant, constant matrix. That's going to be that one there. And so I can solve this very quickly by taking the inverse of A and multiplying by B. So A inverse B is going to give us the X and the Y value. And so again, if we're just solving the system of equations, we're going to do that as an ordered pair. So it's going to be 17 over 8 comma 13 over 8. That is going to be the solution to that. So now I'm going to take the time and go over to Desmos and do this calculation using the Desmos calculator. And so again, we're going to clear this. We're going to clear out everything because we're going to enter A and B new matrices. And so our first new matrix A, we want it to be a 2 by 2. And so we go back here and we see 4 or 5, -1, 4, -4. So that's what we're going to type in for that first matrix. So I'm going to come over here. I'm going to hit new matrix because I want to do that. And so it was 5, and then right arrow key, and I'm going to hit the minus and then a 1, and then the right arrow key again, 4, and then the last one, and then the last coefficient was -4. So we're going to hit enter for that, and now we're going to hit new matrix B, and here we only want one column. And so this one's going to be our constants matrix, and it'll have 9 and 2. And so we'll just go hit 9 and then hit the right arrow key and hit 2, and we'll enter there. Now we're going to do the calculation. We're just going to go A, we're going to hit that inverse button, and then we're going to go B, and we'll make fractions. And here we can see we have the 17 over 8 and the 13 over 8 that we had shown right there. This method also works for systems in 3 variables, and it's going to make you very, very happy to know how to do this, because it's going to save us just an absolute ton of work. And so here we're going to set up our coefficients matrix, and it's going to be a 3 by 3 matrix. And so the first one's easy. We go 4, we go 3, Z has a coefficient of 1, and in the second row we go 6 for the X, we go 1 for the Y, and we go, oh wait, there's no Z there. That's okay, we have no problems with that, but we do have to have a placeholder in the matrix. So I'm going to put a 0 right there to be our placeholder for having no Z in that second linear equation. And now here in this third one, we have 3 for the x coefficient, we have 5 for the y coefficient, and 3 for the z coefficient. Now we're going to make our constants matrix here. And that constants matrix, this one of course is a 3 by 3 matrix. And this one is going to be a 3 by 1 matrix. So our resulting matrix will be a 3 by 1 matrix. Since we are going to multiply, we're actually going to take the inverse of that. And this constants matrix is going to be 14, 9, and then 21. And then the result, which we'll do only in Desmos, will be equal to the x, y, and z value when we get it. All right, so again, we're going to go back to Desmos. We'll clear this out. We're going to clear all because we want to use A and B again. So we're going to hit new matrix. We're going to hit a plus for rows and a plus for columns. And we're going to get rid of that. And so I got to check my values again. It was 431, 601, and 353. Let's see if I can remember all those. Probably not. So 4, right arrow, 3, 1, and then it was 6, 1, and then a 0, and then I forgot. So let's go back. 3, 5, 1, 3, 5, 3. There we go. So 3, 5, 3, and we'll hit enter. And then we want a new matrix, and that new matrix we want hit a plus for rows and a minus on the columns, and then check. So 14, 9, 21. So 14, right arrow, 9, right arrow, 21, right arrow, and we'll hit enter. And then do the magic. A inverse B, and there we go, done. All the work that we did on the last section done in a couple of seconds, and it is 131. And so our final answer is going to be an ordered triple. So our final will be 131 as an ordered triple. We'll box that up, and we will say we are done with that one. Okay. Finally, a example for solving a system of linear equations. That's a application problem. And so Sumali and Eduardo each improved their yards by planting hostas and ornamental grass. They bought their supplies from the same store. Sumali spent $126 on 9 hostas and 11 bunches of ornamental grass. Eduardo spent $27 on 3 hostas and 2 bunches of ornamental grass. What is the cost of 1 hosta and the cost of 1 bunch of ornamental grass? Okay, so again, just like from the last 2 sections, the variables are in the last sentence, and they are what the question is asking you to solve. And so when I know what the cost of 1 hosta is, so let's go H is my cost of 1 hosta, and we'll go B for the cost of ornamental. So those are going to be our variables. And so here we can start setting up equations from the information that was given. We have something about Sumali, and she spent $126 on 9 hostas and 11 bunches of grass. So if I take 9 hostas and I multiply by the cost of 1 hosta, I'll have that portion of the $126. And then if I take 11 times the cost of a bunch of ornamental grass, I'll have that portion of the $126. So we can write that out as 9H plus 11B will be equal to 126. And then the last piece, that Eduardo spent $27 on 3 hostas and 2 bunches of ornamental grass. So what we can do is we can say that 3 times H plus 2 times B is only $27. Now, since we've set that up that way, it's very simple to set up the appropriate matrices to solve this particular problem. So I'm going to start with a coefficients matrix. That'll be 9, 11, 3, and then 2, and then my constants matrix. And again, we'll multiply by the inverse of the first one. So 126 over 27. And we'll hit new matrix. And that new matrix, we want it to be a 2 by 2. And we'll go back, and so it's 9, 11, 3, 2. So 9, right arrow, 11, 3, right arrow, 2. We'll hit enter, and then we'll do another matrix B. We will reduce the number of columns by 1, and then it was 126, and hit right arrow and 27. I'm fairly certain, but I got to check. 126 and 27. Okay, that's beautiful. We'll go back to here. We'll hit enter, and again, A, the inverse button, B, and so 3 and 9 is the cost here. And so our result here is 3 and 9, and so our final answer is 1 hosta costs $3, and 1 bunch of ornamental grass costs $9. And that is it. Okay, well, that's all I got for today, folks. So have a good day. Goodbye.